Hello, this is our last little video on solving inequalities, and this is going to answer the question of to flip or not to flip, and why. Speaking of, when do we flip the inequality symbol around the other direction? Because sometimes you have to. Okay, so I'm actually going to solve the one on the right first. It does not require flip, and we'll see why. In order to get the x by itself, I need to move the 2. The 2 is connected through multiplication. The opposite of multiplication is division, so we're going to divide. 2 divided by 2 is 1x. What we do on the left side, we must do on the right. And 6 divided by 2 is 3. And if we left the inequality symbol the way it is, we get 1x is greater than 3, or just x is greater than 3. Now I'm going to prove that that is the correct one by picking a number to substitute in for it. So if I'm looking at the number line, I'm going to do 0, 1, 2, 3, 4, 5, 6, like that. And then I can put a negative 1 over here if I want to. Okay. We're already saying that 3 is the target. I'm not going to color it in because it doesn't have an equal sign, and anything greater than a 3 should work. The 4 should work, the 5 should work, the 6 should work, and you can keep going. I'm just going to use the 6 as an example. I'm going to go back to the original equation. And instead of the x, I'm going to leave a space. And what I'm going to put in the space is now something that's greater than 3. So I'm going to put in the 6. Okay, so then I'm going to work this out, and this says 2 times 6, that's 12. Is that greater than a 6? And yes, it is. So that worked. Now I'm going to see if I put in a different number, would it still work? I'm going to leave this in and say, okay, well, what if we just put in a 3? Okay, well, 2 times 3 is 6, and 6 is not greater than 6. So now it doesn't work. That's false. And now I'm going to say, well, what about if I did less than a 3? So the number that I'm going to pick that's less than a 3, I'm just going to use 0 because it's probably the easiest number to use for proof. And it is less than a 3. So 2 times 0 is just 0, and this is saying 0 is greater than 6. So no, it didn't work. Okay, but the 6 did work over here. So in the area that we shaded, what we consider the greater than zone, that a number from there worked. In the area that wasn't shaded, the 0, that didn't work. And I didn't have the 3 shaded, and that didn't work either. So yes, we are correct to say that numbers greater than 3 worked because we had a proof of one in the shaded area when we plugged in the 6. Okay, now I'm going to show the other one. I'm just going to get rid of some of this because it gets kind of messy looking. And I'm going to do this other one. And we're going to see how it works. Okay, so if we solve it the same way, we're going to divide to get rid of that negative 2. And negative 2 divided by negative 2 is a positive 1, so I still get the 1x. And I'm going to divide over here. And 6 divided by 2 is negative 3. Well, if I just brought down the sign, this is what I would end up with. 1x is greater than or equal to negative 3. So far, looks fine, looks just like the other one. Okay, I'm going to draw it. Okay, so I have 0, 1, 2, 3, 4. Over here, I've got negative 1, negative 2, negative 3, negative 4. Okay, and my negative 3 would be here. And I'm not going to shade it in because it doesn't have the equal, but it says greater than, so it would be anything to the right, so I'm going to shade to the right. That's the way it would look, if that is correct. That means if I pick anything in that shaded area and plug it back in, it should work. So I'm going to rewrite my original problem. But I'm going to take out my 0 and leave a space. And now I'm going to put in something that's in that shaded area. Anything in the shaded area should work if my answer is correct. So the easiest one to put in is the 0. So there it goes. Now I'm going to multiply. So I have negative 2 times 0 is 0, and 0 is not greater than a 6. Well, That did not work. 0 is not greater than 6. So this side is not working. Okay, well, let's just try the other side. Okay, what if I put in that -4? Because -4 is not greater than -3, it's actually less. The farther you go out down the left side, the smaller you get. And now we're going to multiply. A -2 times a -4 is a +8. And yes, 8 is greater than 6. It worked if it was on that side. So my graph is wrong. Okay, I actually should have gone from the 3 to the left. So I'm going to switch my graph to reflect the way that we know it should be according to when we plugged in the answers. So I have my 0, 1, 2, 3, 4, -1, -2, -3, -4. 3 is still my focus number, but instead of going to the right, I'm going to shade to the left to show that it's all the numbers less than a -3. Well, if that's the case, if this left side is the one that works, then my inequality symbol is incorrect, and I need to fix it. I actually should have it like this, but that means it flipped because it originally was the other way. So you know to flip it if, and here's the rule, if you are dividing or multiplying by a negative number. We divided by a -2 on both sides, and that causes the inequality to need to flip around because remember, a negative is also an opposite. So once you do it to both sides, you're oppositing. That means you need to opposite the symbol and flip it around. But you only do it when you multiply or divide both sides by a negative. It doesn't matter if your answer is negative, it matters if you multiplied or divided by a negative. Okay, so now we're going to look at one that's more complicated and apply that process. So now I'm going to draw my line. Okay, I still want to get my DCID steps written down here and remember them. Okay, there is no distribution. Combining like terms, we definitely have that because if I look on my left side, I've got 3x minus 7x, and I can definitely combine them. And if we remember how our integers work, when we're subtracting like this, we can change it to addition and attach the negative. And now we got 3x plus -7. But since we got a positive and a negative, we are going to subtract. 7 minus 3 is 4. You have your x, but since 7 is further away from 0 and 7 is a negative, then it controls the answer, so then the 4 is also going to be negative on the x. Now I'm just going to bring everything else down, and that was our combine step. Now we need to do the isolate through plus and minus. And once again, I like to do my x's first, and I like to keep my x's on the left side. So that means I'm going to move that -2x on the right side. And it's a negative, so the opposite of that is positive. So I've got -2x plus 2x, which is a 0x, so that goes away. But then I have to do it on this side. Same thing on both sides. And I have a -4x and a positive 2x. And once again, since one's negative and one's positive, I'm going to subtract. 4 minus 2 is just 2. But 4 is further away from 0, so the 4x controls it. And since it's negative, the answer 2x is going to be negative. Now I'm going to bring down the rest of it. So plus 4, bring down the 10. Now I'm still trying to isolate using plus and minus. I need to get this x by itself. I've got a -2 and a positive 4, but the -2 is connected through multiplication, -2 times x, and the 4 is connected through addition, so I'm going to move the 4. So it's a plus 4, I'm going to use a minus. And 4 minus 4 is 0, so it goes away, and then I'm going to do it to the other side. So then I have 10 minus 4, which is just 6. Bring down my symbol, and I'm going to bring down my -2x. Okay, almost done. I have just finished up the last plus or minus isolate step, but I still need to get this x by itself. So that means I need to get away the negative 2. And that negative 2 is being multiplied by x, negative 2 times x. So the opposite of that is the last D, divide step. So I'm going to divide by the negative. Negative 2 divided by negative 2 is a positive 1, so I get 1x. But then I need to divide over here. And 6 divided by negative 2 is negative 3. But since I divided both sides by a negative 2, that's when I need to flip my sign. So then my answer is x is greater than or equal to negative 3.